Hey everybody, it's Mrs. C, and I am here today to do a little bit of review of, what do we call this? Solving inequalities, graphing inequalities, writing them in different notation. And so I just found a really cool worksheet, whole bunch of problems. There were like 40, I think there were 30, 34 or 30, I don't know, 35 or so problems on just inequalities of different ranges. You see them right here. This is just the, what are these, evens? These are odds. These are odds. And I just thought, you know what, let's give it a try. Let's do a few. Now, I have other videos out there, both on Educreations and on YouTube, that go over the basics, the intuition of inequalities, basic inequalities, more saucy inequalities, as well as compound, and then utilizing set builder and interval notation. So blah, 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 blah. That's all the talk. Let's get into the work. How about we try number 3? I don't know. I'm avoiding number 1 only because of that little fraction. I know that little fraction freaks everybody out. So let me write number 3 here. We got x plus 7. What sign is that? Guys, you know what that is? That's the greater than or equal to 12. And then we got this interesting little component. I'm going to change my colors. I'm going to go to maybe a blue, to the 9x. I know I skipped a word. I'll be there in a second. Less than, right? Negative 45. And so we had the word. What's the word? The word is the word. I know you guys like when I sing. I think I got a lot of fans out there that like that song. So I'm trying to write. There it is. Or, all right. So what have we got here? We've got 2 inequalities and a compound word, the word or, in between them. So I'm going to ignore the word or for now. I'm just going to solve these little babies here. So minus the 7 from both sides. I think we would all agree the process here is pretty straightforward. 12 minus 7 is 5. So there's one little partial solution here because there's another one on the other side. So I have a x being greater than or equal to 5. So if you think of that, you know, well, let's think of it later. Let's just do the math right now. Let's divide both sides here by 9. And we would have x is less than, what's negative divided by positive is negative, and 45 divided by 9 is 5. So we have a negative 5. So if you think about the intuition of these 2 little individual problems, I'm doing a little intuition, a little graph, a little practice, a little bit of everything here. If I come over here to the red, and you take a basic number line, right? And you know how to do this. And you graphed the number 5 on the number line. Back in the day, you would have done a solid interval or a closed interval or a solid circle or whatever you used to say, right? The solid, and then you would have shaded this way. Now, if that is at all confusing to you, if you're thinking, why did you shade that way? Maybe you need to go back. I'm just saying, just suggestion. Go on back to some of the other inequality, just solving basic inequality intuition videos that I have, and just do a little refresher before you do this video, because I don't want to overwhelm you. But just to say here, if you just look at it, it says clearly that x is bigger, right, than 5. So all I really did was shade all the values that are bigger than 5. Now, on a number line, numbers that are bigger than 5 go to the right. And it's pretty much that's it. It's just nothing harder. It's nothing, oops, oh my goodness. What is that? Sorry. That's my little trick of getting rid of things so that you don't have to look at them. And we've been through this, haven't we, on other videos that I now will take an hour to try to fix my mistake. Now, of course, my pen is going to be too big. I got it, I'm here. I'm going over to the blues, people. And if I had just thought about this one by itself, I would have graphed it like this. And I would have had an open circle because it was a less than sign only, and I would have shaded to the left. That would have been shading all of the values that are actually less than negative 5. That's everything smaller than negative 5. That would be to the left of negative 5. Now, the interesting thing here, though, is that we weren't asked to graph these individual. This isn't good enough. 2 graphs, not good. So when you put red and blue together, what do you get? I don't know. Like, come on, my art people out there. If you combine red with blue, the result is... No, not green. What are you thinking? What do you mean green? You know what? Just stop right now. Red and blue makes purple, doesn't it? Go ask your art teacher. She's going to know. I'm saying red and blue makes purple, and I'm going to show you why I want to do that. I'm going to draw a number line. That's not purple. I know it's not purple. I'm going to put all the players that were in the red and in the blue. I'm going to put them on my nice number line here. Well, I had a, see over here, I had a negative 5. I had a 5. I would go there. And I had a negative 5 that would go on this side, right? So I'm just putting all the numbers that were in the original problem. And now I'm going to show both shades. Now it says that the answers that satisfy this problem, and that's the original. Do you remember the original? It said x plus 7 has to be greater than or equal to 12, or option 9x, 9 times x had to be less than negative 4. So when we see that it's an or, both of those solutions must graph on my number line. And so now let's see where I had my 5, and I said I wanted to pick a new color, purple, because I wanted to represent that this is everybody together. So I have the new value of 5. Now recall that we use interval notation on the graph, so I don't use a solid circle, I use a bracket, and I don't use an open circle, I use a parenthesis. That's not a big deal. Just switch from, excuse me while I shift, just shift to brackets and parentheses. It's easier in the long run. And watch how cool this is. Are you ready? Where you see a bracket, look over here, just put the bracket on the 5, just kind of recopy what you just did. See? That's just like a little mini that. It's just on a bigger number line, right? So I really didn't do anything much there. Now do this. Take this here and graph it there. That would be a parenthesis and a shade. That's it. Now, I know you might be saying, I don't get it. Well, okay. I'm all right with that. You don't have to get it. I'm cool with you not getting it right now. Can you just replicate it for now? Can you just say, okay, I put this here and I put that there, and then my final answer is, well, what's your final answer? Your final answer, as crazy as it might sound right now, because this is kind of new to you, where'd my colors go? I know you hear me on this thing trying to fix this. This is actually your final answer as a graph. And your final answer in interval notation is, you're going to have to probably rewind this because I am about to cover some of this stuff up, okay? So if you want to see the original process, you're going to have to just go back. That's the beauty of digitization. You can always rewind. Okay, so my final graph answer, just to clean things up, because I have not yet still, I know you hear me complain about this all the time, I haven't switched to my new program yet because I don't know it well enough to work quickly on it. But very soon, coming soon to a YouTube near you, I will be switching to a new app to do my presentations. I'm excited, but not yet. Okay, I cleaned that up. I'm not going to erase this time. I'm going to use my white. I got it. Okay, guys. And the beauty is you can fast forward too, right? You don't have to listen to me going through all of this. So here's the deal. That's set. That is it's not set notation. That's graphing. Graph notation, graphical notation. I don't know the appropriate, verbiage, but we graphed the solution. Now, if you recall, we actually also had the solution. This is called set builder notation. We had the first answer that we got, I believe, was the positive 5. That's what I'm thinking it was. That was this constraint over here. And then the negative one was over here, but we actually, if you remember, we got the positive first. It doesn't matter. I like to write my answers least to greatest. So we have the x, right, and we have the -5. And then set builder notation uses the less than or the greater than symbol. So in this case, if you recall, it was that. And this one over here was an x and a 5. And, oh, I see my mistake. I got it. Thank you, guys. I didn't have a line underneath that one, did I? Caught it. You're good, man. You got that. You got eagle eyes. Okay, then we come over to this one. I was too confused. I was too focused on making sure I put the little, greater than or less than sign fit in the right direction. I didn't want to screw that up. Okay, so that's my set notation with the word or in between. And then the last step is to write it in interval notation. Now, interval notation is awesome because it just writes what the graph looks like. Now, warning, if you haven't done my intuition videos on interval notation, this is probably going to look a little freaky to you, so I don't want to freak you out. Let's come up here, put our negative infinity, infinity. Okay. And it's as easy as this. And I am going to actually get rid of my set builder notation so that I can do my interval notation right underneath my graph. So important for me to do that so I don't mess up. So here on this side, we put our negative infinity, recalling that negative infinity or infinity always have a parenthesis. You cannot contain what is infinite. And then on this side, just copying it. See that? I'm just actually writing what's there. I mean, it really is just the sweetest little thing. Now, the last step is you don't do this. You don't write or on interval notation. That's considered tacky, my children. Why? Because it's using two different types of notation. You're mixing set builder with interval. Now, interval has its own notation for ands and ors. Do you know? Have you seen it? If you've watched my videos, you already know. We have a open U. A union, actually, is what that stands for. Union. Any of these where you see an and, you see them over here on the left side, you see the ands? Interval notation for an and is an upside down union. It's the symbol for intersection in mathematics, and I think of it because it looks like the letter N, and, and is like that. So that's, and I have videos on intuition where I talk about that. So for now, let's just take a gander, if you don't mind. I think I'm going to clear my slide. No, if I clear my slide, it's all going to go away. So I'm going to clear my slide. It's okay. All is well. Whoa! Where'd it go? Hang on, I'll fix it. Okay, I'm back. And there's the whole thing. It was actually only 32 problems. So, this is, by the way, guys, this is in your drive. I know when you're watching it on YouTube, it's really kind of small and hard to see. So I just wanted to throw it back up here before I wind up going and erasing it, because I want to be able to just do a couple more problems, maybe without all the blah, 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 right? If I know I always say that, but I'm going to really try. I'm going to try to just, I don't know what just happened there. Okay, I'm going to try to just do a couple problems. Shall we try, I don't know, which one looks good to you? Let's do 15. Now, I want to do 15 because 15 actually looks a little different, and I don't know how many of these I've done yet, so let's go ahead and write number 15. 11 is less than 8 plus k, and it's also less than or equal to 12. Okay, so 11 is less than 8 plus k, and it's also less than or equal to 12. Now, you heard me say the word. I said, and it's also less than. I didn't say or, because they're kind of all trapped together here. They depend upon each other. So this is kind of one of those hidden ands or it doesn't actually say and. Now scan off to the left side and you're going to see problems that actually use the word and problems that use the word or. You're going to see problems that don't have either. But the ones that don't have either look just like this, with a variable kind of in the middle and stuck in between two signs. These are always ands. And so they're graphed like ands. And so let's go ahead and give this a shot. Now there are two ways to do these problems. There's the long way and there's the short way. I'm going to do the short way with you because I think not only doing it because it's short, but because there's less room for screwing up. So if I divide my field, you're going to notice I actually put the line down the 2 because I do have 2 lines. Now, up until now, I've always said, don't put 2 lines. You only have 1 line. There's only ever 1 line. Well, that was before we got to compounds. Now, compounds will have 2 signs. So what do? Well, the rule is pretty much the same, guys. Whatever you do to one side, you do to the other. All of the other sides. So to get k by itself, what do we have to do? We have to minus 8. No biggie, just minus 8 from everybody. It's really kind of cool if you look at it. Cancels out there, right? Comes over to the left, 11 minus 8, that's 3. Bring down the inequality, bring down the k, bring down the inequality, and 12 minus 8 is 4. That was it. And that, there's something said about doing it a faster process way, because the other option would be to separate this into 2 separate inequalities and solve them out individually and then bring them back together. Can I just say, ew, don't want to do that. I think I would probably screw that up at some point. So now that it's written like this, guys, I will always jump right to my interval notation and my graph. Now, what would be easier for me to do? Graph it? I love graphing them when they look like this. Because think about it, guys. K stands for all the values that fall between 3 and 4. That's what K is. That's why K is in the middle. It's between them. Set builder notation is always expressed from least to greatest, unless they're trying to trick you. They're going to put the lesser value on the left. Then the signs will always open to the right. And then over here, they'll put the greater of the values, which is just what a number line does, right? We start with the negative infinities, we proceed through 0, and then we end with all the positive infinities, going from the lesser to the greater. So how exactly do you write this? We'll put all the players on the board. You've got a 3 and a 4. Now, you're probably thinking, why'd you put all that left to 0 stuff? Well, because I always put 0 in the middle. I am a creature of habit. 0 in the middle, and the other numbers will fall where they fall. So let me get another color, because it just feels like I should have another color. How about the purple? I like purple. Now, see over here on 3, the symbol was a open interval. That means I'm using a parenthesis. And then if we look over here, I have a closed interval. That means I am using a bracket. I make them face each other because I know I'm going to shade in between. Hoo-hoo! That's my answer. That's my final answer. That shows that all the answers that satisfy the original condition will fall between 3 and 4, not including 3, but including 4. Last step, the easiest step, write it in interval notation. You're going to come to find interval notation is the easiest thing that we do in this class. Pre-calculus skill, easiest thing that we do in our Algebra 1 class. Shall we try one more? What am I timed at? Oh, I'm at 20, but you know what? What the heck? I'm just going to try one more because I'm having so much fun. I don't want to stop. I don't want to stop and get ready to go to work. I just want to keep having my own little math party here with you. So, do you see any that look saucy? See, I'm trying to read your mind. I mean, they all look kind of easy, and they all kind of look hard all at the same time. I see you looking down at those 20s. Shall we? I'm just trying to figure out which one. Let's do an and let's do great googly moogly. I don't know which one. I really don't want to get a no solution. I want to do another video on no solutions. I don't want to stumble upon a no solution accidentally. All right, I'm just going to go for it. I can't pick my color. Will pink make it all right? Yes. I hear all my pinks out there. My color-coded classes that I have back at school, I hear my pinks going, woohoo! Chill, people. I already did blue. I did purple. And I've done red, haven't I? Haven't I always used red? Red's my go-to color. All right, which number did you say? Well, I know you didn't say it. I thought I said it. Maybe I didn't. I'm going with 25. 25 looks so saucy. All right, I'm going to write it. You can go ahead and fast forward, get through this process here. All right. Okay, so it needs to be said that these pretty much are the hardest that they're going to get. And you're going to notice that the inequality work gets a little bit bigger, so we're kind of made to do a little bit of extra work here, and meaning to get it into set notation. So just going to do some moving around here. I made my pen a little bit thinner because I couldn't even fit the other side of the problem. If you're wondering, where did the other side of the problem go? I didn't even write it because I didn't think I would have enough room. And I'm talking. I'm probably going to screw this up. Stop distracting me. Adding my 9 to both sides. I have x is less than 19 if I did everything right. So x is less than 19, and I probably should check this. I'm going to put it up here. X is less than 19. I'm just going to go and erase that so that I can do my other problem. And you can see how you don't have to do them at the same time on your board. You can do the two separate problems. Just don't forget about the other one. So that was, what did I say? That was number 25. So the next part of 25 is 5 plus 7x less than or equal to 10x minus 10. So you see, this is an and that was not written in its kind of compound form in set notation, making us do two separate problems instead of working just one big one with three different sections. Oh, my goodness. Well, I'm going to move my negative. I'm going to minus 7x from both sides, actually, on purpose here. Show you a little something that's maybe a little bit different. And I'm going to have, what is that going to be, a 3x? Minus 10, and then I'm going to add 10 to both sides. I'm going to have my 3x this time on the right side, and I'm going to have 15 dividing by 3. So see, a little bit of, saucified little two-step equation. Nothing hard, nothing easy. All right, so hopefully I did that correct. And again, guys, your check steps always still work if you take that 5 and plug it in here and here. Right? You just evaluate. 7 times 5 is 35 plus 5 is 40. And then the other side, 10 times 5 is 50 minus 10 is 40. That check step will show you that both sides are equal, even though that says inequality. The check step, you think of it as an equation to see if both sides match. So now, I'm feeling fairly confident, wishing I had actually checked the other one to make sure I was right. So let's hope, right? And here's the situation. We need to write it first in set notation, and I've left them split up. How do you write this in set notation? You can write it with an and, but there are some constraints you must follow. First of all, I always want the x on the left side. So do you see it over here? The x is on the right. Did that on purpose. The x should be on the left. The 5 should be on the right. Now, if you go swappy like that, I want you to make sure that this inequality gets swappy as well. So if you notice, the inequality was opening to the x. So when you swap it, you must make sure that it is still opening to the x. So here is your first way. You can write it like this. X is greater than or equal to 5 and x is less than 19. That's option number 1. Option number 2 is to write it with the x in the middle. You put the lesser number on the left, the greater number on the right, and then you make sure, again, your signs are opening in the right direction. You might be saying to yourself, why did I go and swap it? Now I got to swap it again. Depends on which form you decide you're going to write your answer. If you write it with the lesser on the left and the greater on the right, these should both always open to the right, unless it's a no solution. But I'm not going to go there. So right now, that is the other way of writing it. What am I missing? Well, number one, I'm missing my graph. Graphs are easy to do from this because, as I told you, it graphs the way it looks, right? So it's a closed interval on the 5, which we used to do the little closed circle, right? And it's an open interval on the, the 19. So it's an open circle, and you're shading between those. Now I'm going to make a little correction because I told you I don't want you using those. I want you using bracket parenthesis. So that's a pretty simple fix, right? The last thing to do is to write it in interval notation, which is easy from this graph. We would just write bracket 5, 19, parenthesis. So those are all of your solutions. This one is set notation. This one is the graphical notation or the graph representation. This one is interval notation. And just so you know, just as a reminder, the answer key for 1 through 33, including the 1 through 32, including the evens, and I know 32 is even, so just saying, they're all available to you on your drive. You'll be able to see these problems a little bit better, and my goodness, plenty of practice for you, right? All right, guys, I'm going to leave you to it. Plenty of work for you when you're filling in your video log. Throw a couple of these down in your extension section and go ahead and record the answer. It's on your drive. When you come back to class, we can start off with some of that saucy practice. See you on the flip side, guys. Peace.